Hello guys, and welcome to today's video where I'm doing a part 2 on differentiation and looking at specifically equations of tangents and normals. Okay, right guys, this video was recorded on Wednesday the 27th of July 2021, and this video guys, and this lesson is appropriate for A-level math students for OCR, MEI, AQA, EdExcel, and all the other international exam boards and relevant exam boards for A.S and A2 level math. So it's appropriate for year 12 and year 13. And it's appropriate for GCSE further math students. So those of you doing the extended qualification, I believe it's the AQA spec and OCR and EdExcel. This is also appropriate actually for like that actually, okay? And if you haven't seen my part 1 actually, then please go and check out my part 1 that I made on Monday, I believe, for this guys, okay? Right guys, if you found my video useful, please subscribe to my channel at the end, drop the video a like, and also turn on post notifications by pressing the bell icon next to the subscribe button so you don't miss out on my further and regular uploads during summer 2021. Right guys, so let's just start with the video today. So I've got a function, okay, so I've got a function f of x equals x squared, and I want to work out the equation of the tangent at x equals 4. Now a tangent, we said before, is a line that touches the curve at one particular point. So x equals 4 will be roughly here, okay, so it's drawing like a line that is what I call like a tangent to the curve. So to work this out using differentiation, what I've got to do firstly is differentiate the function. So work out dy by dx. So differentiate x squared, guys, it goes to 2x, okay? So if you're not happy with that, then please go and check my previous video on that. So the power comes down by 1 as a multiplier, and then the power also comes down by 1. Okay, so dy by dx equals 2x. I want to work out the equation of a tangent at x equals 4. Well, the gradient at x equals 4, when I sub in x equals 4, is going to be 2 lots of 4, which is 8. So the gradient of my function at x equals 2 is positive 8. So I've got the gradient and I've got the x coordinate. Now all I need is my y coordinate. So I sub in x equals 4 back into f of x, or y equals the function of x. So y equals 4 squared, which is 16. So 4 squared, sorry, x equals 4, sorry, I apologize, y equals 4 squared, which is 16. So I've got my coordinates and I've got the gradient. So I'm going to use the formula y minus y1 equals m brackets m minus x1. Okay, so it's using this formula here. So equation of a line, guys, is always in the form y equals mx plus c. But when you do your A-level maths, guys, it's important to get into the habit of knowing this formula. So it's important to know where x1 and y1 are your coordinates and m is just your gradient of the line. Okay, at that particular point. So substituting this in, guys, I'm going to get y subtract 16 is equal to 8 brackets x minus 4. Okay. Expanding my bracket on the right hand side, I'm going to get y subtract 16 equals 8x minus 32. So expanding the bracket, 8 times x is 8x, and 8 times negative 4 is negative 32. Okay, rearranging this so it's in the form of y equals mx plus c. Okay, so adding 16 to both sides, I'm going to get that the answer is going to be, oh, sorry, mx plus c, not 16, sorry, mx plus c. Okay, so let's just rub that out there. Oops, rubbing out. So rearranging this, I'm going to get 8x minus 16. Okay, so that's my equation of the tangent at the point x equals 4. So differentiating the function, substitute the x coordinate into the function, okay, to work out your gradient at that point, and then work out your y coordinate by subbing it in. Okay, right, next part, I want to work out the equation of the normal at x equals 4. So equation of normal, guys, so it's perpendicular to the tangent. So it's asking for this line here essentially. So that is, so the bit that's in yellow, that is the equation of my tangent. Okay, I've put it in darker orange there. So it's the negative reciprocal of my tangent gradient. So the gradient is 8. So the perpendicular gradient is going to be the negative reciprocal. So it's going to be minus 1/8, guys. Okay, the coordinates stay the same because it's going through the same point. So it's going to be y minus 16 equals minus an eighth brackets x minus 4. Okay, so this will be my answer for this question. Now, expanding the brackets and rearranging it, I'm going to get y is equal to minus an 8x, 1/8x, and then I'm going to have plus a half there, plus 16, so it's going to be plus 16.5, or 33/2. So either way is going to be correct. So that is the equation of my normal. So that's how to work out the equation for my normal. So it's the negative reciprocal. So it's the flipped version and negated for the tangent. So the tangent is always subbing in to d over dx or f dash of x. The equation of the normal is, so the gradient is the negative reciprocal, so it's perpendicular to the tangent line. Okay, so I hope that actually made sense, guys, and comment below if you're not sure about anything that I've put on this first slide. Example 2, find for each of the following curves, find the equation of the curve at this point. So we've got part A here only. So y equals this function here. So dy by dx, okay, is going to be 2x minus 9. So differentiating x squared goes to 2x, differentiating minus 9x goes to minus 9. Substituting in x equals 6 to work out the gradient at x equals 6. So 2 times 6 is 12, minus 9 is 3. So the gradient is equal to 3. Now finally subbing in the x coordinate to work out what the y coordinate is. So x equals 6, y equals 6 squared, which is 36, minus 9 times 6, which is 54. Plus 13. So I'm going to have, okay, 36 subtract 54 plus 13. Now 36 plus 13 is 48. 48 minus 54, sorry, is negative 6. So the y coordinate is going to be minus 6. Okay, so now I can substitute in my equation. So I'm going to have y minus y1. So y minus 6, which is y plus 6, equals m brackets x minus x1. Okay, so drill that formula, guys, into your head. Y minus y1 is equal to m brackets x minus x1. Okay, and it's always in the form y equals mx plus c, which is the straight line form, unless stated otherwise. Now I know for the Edexcel and the AQA spec, sometimes it's in the form of ax plus by equals c. Okay, so it is just obviously recognizing on how to rearrange the equation into that form. But generally speaking, it will always be in the form y equals mx plus c. But I am aware that other examples like Edexcel and AQA will ask it for in different forms, ax plus by equals c or bx plus ay equals c. Okay, right guys, so rearranging this, okay, expanding the right hand side, I'm going to get y plus 6 is equal to 3x minus 18. Subtract 6 on both sides, I'm going to get y is equal to 3x minus 24. Okay, and that will be my equation of the tangent. So that is the final answer for that question. Okay, and these questions would typically be worth 3 or 4 marks on A-level papers, but it will normally be like a sequence. So part A will ask you to differentiate, part B will say to you work out the gradient given this point, and then part C will say work out the tangent of the equation, and then part D might ask you for the equation of the normal. Now remember, if it's normal, it's the same equation, but it's minus 1 over m. So the equation of normal is the negative reciprocal of the tangent gradient. Right, guys, a few more examples. Okay, example number 3. So we've got a function here actually, f of x equals 2x cubed plus x squared actually minus 18x plus 2. The points, so full stop actually, the points A and B lie on the curve y equals f of x. The gradient are at both A and B is 2. Find the coordinates of A and B. Well, we are given, so the gradient actually, so we're going to work out f dash of x, and then we're going to make that equal to 2. So differentiating this, guys, I'm going to get 6x squared. Oops, sorry, that was my mistake. So 6x squared plus 2x minus 18. Okay, so that is the derivative. Now, it's saying that so points A and B, okay, they have a gradient of 2. Okay, so it's not saying that the coordinates are 2. It's saying that the gradient is 2 at that point. So we've got to set f dash of x equal to 2 and then solve the equation, essentially, if that makes sense. So set f dash of x equals 2 and then solve it. I'm going to get 6x squared plus 2x subtract 18 is equal to 2. So the derivative is equal to 2. Okay, bringing the 2 to the left-hand side, so minusing 2 on left-hand side, I'm going to get 6x squared plus 2x minus 20 equals 0. Okay, so now I've got a quadratic that I can essentially factorize. Now, what I can do is divide everything by 2 to make it easier. So factor out a 2. So I'm going to get 3x squared plus x minus 10 is equal to 0. Okay, so solving this now, okay, is a bit easier. So I'm going to have 2 brackets, and then I'm going to factorize this. Now, I've done this earlier before I did the video, just so I'm actually happy. So factorizing it, we should get 3x minus something, and x plus 2, I believe, and then minus 5, because 3x times positive 2x is positive 6x, minus 5x, which is positive 1x, and minus 5 times positive 2 is minus 10. So they are my solution. So solving this now, guys, I'm going to get that x is 5/3 or x is negative 2. Okay, and then I've got to now work out my corresponding y coordinates for each by subbing that in to my answer. Okay, so I might have to use a calculator for this. So subbing this in, guys, so when x equals minus 2, okay, doing this on my calculator, I'm going to get so 2 times negative 2 cubed is minus 8. Minus 8 times 2 is minus 16. So it's minus 16 plus 4, which is minus 12, plus 36. So 36 minus 14 is 22. And then add 2 is 24, I believe. I think that is correct. Okay, and then subbing in 5/3 obviously is a bit more trickier. I'm going to have to check my answer on Google here. Okay, so subbing in 5/3, well, 5/3 cubed is 125 over 27. Okay, and then I'm going to times that by half, and then I'm going to add 5/3 squared minus 18 times plus 2. Now, on my calculator, obviously, it's giving me the decimal answer. I've got minus 15.962962.963. So I'm going to say, can I change this to the fraction? No, I can't. So minus 15.96 to two decimal places. Okay, I think I might have made a mistake on the substitution, guys. Okay, but essentially what I did was sub in 5/3 into there and then sub in x minus 2 into there. For minus 2, I think the answer is correct, because minus 2 cubed is negative 8 times 2 is minus 16. Minus 16 plus 4, because minus 2 squared is 4, is minus 12, sorry. Minus 12 plus 2 is 10. Okay, minus 10. And minus 10 plus 36, sorry, should be 26. So the y coordinate should be 26 there. Okay, and the y coordinate for this one should be minus 15.96, or it might have given you the fraction answer. Okay, so comment below if I have made a mistake here on example 3, guys, and let me know actually. So the coordinates of A are going to be this, so 5/3 and minus 15.96, and the coordinates of B are going to be negative 2 and 26. Okay, so I hope that actually made sense, guys. Right, guys, so last example actually for like today's lesson. So y equals 2x cubed plus 5x squared minus 7x plus 10. Find the equation of the tangent at the point x equals 1. Give your answer in the form y equals mx plus c. So the first thing we're going to do, guys, is differentiate the function. So dy by dx is going to become 6x squared plus 10x minus 7. Okay, substituting in x equals 1 into dy by dx, I'm going to get 6 times 1 squared, which is 6, plus 10, subtract 7, which is going to be 16 minus 7, which is equal to 9. Okay, I've now got to work out my y coordinate by subbing in x equals 1 into here. Well, I'm going to get 2 plus 5 minus 7 plus 10. Well, that's just going to cancel out actually, because 2 plus 5 is 7, minus 7 is going to be 0, so y equals 10. Okay, so y equals 10 when x equals 1, guys. I'm now going to use the formula y minus y1 is equal to m brackets x minus x1 to work out the equation for my tangent of a straight line. Okay, so y minus 10 is equal to 9 brackets x minus 1. Okay, expanding this out, guys, I'm going to get y minus 10, expanding the right-hand side, I'm going to get 9x minus 9. Adding 10 to both sides, I'm going to get y is equal to 9x plus 1, or 1 plus 9x. Okay, so 9x plus 1, which is in the form y equals mx plus c, where m is 9 and the c is 1, okay, at this given point. Okay, so I hope that made sense, guys. Okay, if the question asks for a tangent, it's always subbing in the x coordinate into dy by dx, or f dash of x, or the first derivative of my function. If it's asking for the equation of the normal or the gradient of the normal, then it's the negative reciprocal. So you'd work out your tangent gradient, and then you work out the so it would be minus 1 over that gradient actually. So if the gradient was 2, let's say, it would be minus a half. If it was 3, it'd be minus a third, and so on and so forth. So the normal gradient is always the negative reciprocal of the tangent gradient. Okay, so the normal gradient is always minus 1 over m. Okay, where m is your gradient for that straight line actually, or for that function at that particular point. Okay, so it's always the perpendicular to the tangent line, okay, as you saw in the first slide. Okay, so that's it, guys, for today's video. Okay, right guys, thanks for watching. So thank you for watching. Please like, comment, share, subscribe, and also spread the word around actually and tell your friends and family about my YouTube channel. Okay, help me reach 1,000 subs as soon as possible. Okay, share this video around with anyone that might find it useful for Key Stage 3 Maths, GCSE and A-Level Maths. Okay, feel free to check out other useful YouTube channels which are Ginger Mathematician, okay, the GCSE Maths Tutor, T Majid, Corbett Maths, TR Maths, and there's many more. Okay, and my last point, guys, to mention actually, I've done a collaboration with Ginger Mathematician actually. So there is going to be a video on fractions going live on his channel tomorrow at 12 p.m. So it's Thursday 12 p.m. on his channel. So please go and check out that video on fractions where I did times and dividing, and my other friend actually did the adding and subtracting of fractions. So feel free to check out actually. So Thursday 12 p.m. guys, on the 28th, okay, of July. Okay, so it's going to premiere tomorrow. Okay, so that is quite an important announcement, guys. Okay, so feel free to check it out on his channel. Thank you so much for watching. Take care, and I'll catch you in the next one. Happy Wednesday. Bye for now.